Hello guys, this is Harsh Paldava and today we are going to perform a regression analysis on stock returns using Python. So let's get started. It's the one and only Digo Double G. Okay guys, here you can see my Jupyter notebook interface and I have imported a lot of packages over here like NumPy, datetime, matplotlib. Obviously you need all of these and some are built in and others you may need to install depending on what version of Python you're using. So yeah, so these are the prerequisites. Without this, you can't perform your regression operation. So do not forget to install any of these. And after installing all of these, we can start with our regression operation without any problems. Okay, so let's get started. Items over here is this is a variable items Tesla and GSPC. GSPC is nothing but the S&P 500. So what we are gonna do today is regress the Tesla's stock returns against the S&P 500 for one whole year. That is from 1st January 2020 till date. That is January 13, 2021. Okay, so just let's call our data over here. Everything's ready. We are gonna call our data using data reader from Yahoo Finance. The start date is 2020 January 1st. Okay, let's get started. Data and okay, so we have got our data over here. So we don't need high, low, open, volume. We just need the close for our purpose. So let's just type in close and just call the data again. Okay, here we get the data. Now let's just calculate the returns. It's just simple high school math. First, I'll type the formula and then I'll explain it to you what it means. It's just okay. No, it's not returns. 1 minute. Data divided by data dot shift one, and then we have minus one, and then returns. Here you go. Okay, simple math. What does data resemble? Data resembles the row. Okay. What does data shift dot one resemble? The previous row. So 86 divided by 83 minus 1 and you get the returns. And why are you getting NaN over here? Because there is no data in the previous row. So how will you calculate the return for that particular day? As simple as that. Now let's start with our regression operation. First we need to assign the variables, the independent variable and the dependent variable. In this case, the independent variable is nothing but the index return. The index returns, that is nothing but the S&P 500 returns. So GSPC and okay, and Y is the Tesla stock returns. So returns, and we have TSLA. Cool, and then we can draw a scatter plot. So PLT dot scatter x comma y. Yes, here is a scatter plot. So PLT dot scatter, uh, we can use this function using the package matplotlib which we have imported already over here. As you can see, import matplotlib dot pyplot as PLT. So we are just applying that function over there. Okay, we are just calling that function. So yeah, and now supposingly if you want the data points to start from a previous number, let's say here it's starting from minus 0.10 on the x-axis, right? Now I wanted to start from, let's say, minus 0.20. So what I'm gonna do is it's pretty simple. We are just gonna do plt dot axis and then just mention, let's say, minus 0.2 comma, and it's ending at 0.10 on the x-axis. Let's say I want to end it on minus 0 plus 0.2, and for the y-axis starting from minus 0.2, so I want to start it from minus 0.3. It's ending on plus 0.2, so I want to end it on plus 0.3. It will make the axis bigger and clearer, nothing else. It's your wish. Yeah, as you can see, now it has started from minus 0.2 in case of x-axis and 0.3 minus 0.3 in case of the y-axis. Okay, so now let's perform our regression analysis. So first we need to assign a variable to add the constant. So x1 will be nothing but sm dot add constant to x, and regression equals to uh, sm dot ols, and we have x comma y. First we have the dependent variable, that is nothing but y, and we have x1 and dot fit. Okay, so so sm, what is this sm over here? This sm is nothing but the stats models dot api, and again it performs stats functions, and we have applied it over here. Dot ols, ols is nothing but the ordinary least squares, or what you popularly know as the linear regression method, the most common method of doing regression analysis for univariate regression analysis. And we have applied the dot fit, the line of best fit to find the regression. Okay, so now let's just get the regression summary over here. Okay, before that, what we need to take care of is we need to remove this row, because if we do not remove it, we cannot perform our regression function. So it's simple, just write this code over there, returns equals to returns dot drop. Okay, and just mention the index number. Okay, so why I mentioned 0 over here, because in Python the numbering starts from 0. So this is row number 0 and this is row number 1. So now you want to remove this row, right? So you need to mention in index 0, and the axis is 0 because we want to remove a row. When we want to remove a column, we'll put the axis as 1. In case of columns, it will be axis equals to 1. In case of rows, it will be axis equals to 0. That's it. No major issue. Then again, we can calculate the returns over here. As you can see, it's 0. The first row has been removed, and now I think we should be able to get our regress. Okay, there's a problem over here. Okay, just a minute, I think. Yep. Let's check it out now. 1 minute. I think I have to execute this as well first. Yes, here we get it. Okay, so what are the results? The dependent variable is Tesla. Yeah, that's understandable. R squared is 0.224. Now, what does this R squared tell us? So 0.224, it just tells us that only 22.4%, okay, of Tesla's movement is explained by the S&P 500. Okay, the rest of the percentage, that is around 78%, okay, that movement is not explained by the S&P 500. It's due to other factors. Okay, so that's our R squared. Basically, when you have a R squared figure of more than 0.5, your regression is more accurate. Your regression results are more accurate. Here we have the R squared less than 0.5, but somehow, okay, we'll get on with it because that's the purpose of this video. Okay, so the constant is 0.0094. Now, the main application of regression analysis is to predict. Okay, predict the returns. So let's assume that for a given period, the S&P 500 goes down by, let's say, 10%. Okay, so if it goes down by 10%, what will happen to the Tesla stock? Okay, so for calculating that, simple, the equation which we learned in high school, y equals to mx plus c. The m here, the m part of it is the beta, which is nothing but the slope. The beta is 1.24, meaning that when the S&P 500 makes a move, the Tesla stock makes a move 1.24 times equal to the S&P 500 move. Okay, so as simple as that, you can just do 0.0094. That is nothing but y plus what is the slope, 1.24 into, and we're assuming that the market would fall by 10%, so into minus 0.1 minus 0.1. Okay, so whenever the market would fall by 10%, whenever the S&P 500 would fall by 10%, you can expect Tesla to fall by 11.46%. And as we look in the scatter plot, yeah, we are accurate, but not perfectly accurate. And the standard error explains that basically what the standard error says is there will be a variation in the range of minus 0.143 to plus 0.143. Okay, so nothing is 100% perfect. Okay, so yeah, guys, this is it. And supposingly, if you want to decorate your chart or something, so you can do it in this way. Let's say you want to label the axis, so plt dot y label, you want to label it as plt dot label. This is only for presentable purpose. So yeah, this is the SNB 500. Okay, just execute it. Yep, here we go. Okay, guys, thank you so much for watching. If you like the video, please hit the like button and comment,
Yeah, yeah.
share.
You
Thank you
know
so
the
much.
West Coast is